Okay, we're on to Module 2, Program Flow. Once we finish this module, we've covered all of really the core concepts in programming and the core concepts in the language. There are a few more little things that we'll introduce later on, but once you've seen all of this, in theory, you should be able to really actually write programs. Now, in practice, you're going to have to practice a lot before you're going to be able to do that if you're starting from ground zero. If you already know some programming, most of what you're learning right now is the syntax, and you already know how to write programs. So again, back to the first thing we looked at Module 1. These are the various things that you can do in programming. You can store data, you can operate on data, you can control the flow of a program, and the program can interact with the outside world. So we've already talked about data storage. That's what we just finished going over in Module 1. We've talked a lot about statements. We still have to talk a little bit about functions and methods in more detail. And now we're going to talk about program flow. And this is really, you can't really write programs until you've covered this material. So let's say you have this problem. How would you display a table of x versus sine x for all of the values from 0 to 2 pi in steps of n over 4? So based on what we know so far, you would have to do it pretty much like this. Don't forget to import math, but then you just have a series of print statements where you print out all of the different values. I'll point out that pi, the variable pi, is defined by the math module, as well as a couple of other constants. So you can just use pi as pi. That works. It does what the question says, but it's not really a very efficient way of doing it. We could could make this a little more straightforward conceptually, right? We could define all of the values we want to take the sign of, and then we could put a series of print statements in like this using the concept of lists that we just learned. But again, having a whole bunch of print statements isn't super fun. And what if I changed the problem so you were doing it in steps of n over 64? Then you'd have to have this massively long program printing out each possible answer. So the solution to this is that you need to have some way of repeating things, of doing things over and over again. And that's what these methods that we're going to talk, these statements we're going to talk about next allow you to do. So these are the basic program flow control statements that exist in the Python language. The first one is the for loop. The second one is the if statement, which has additional options to it with the elif and else options. These all go together with if, and then there's the while statement. So we're going to go through these things sort of one at a time. Actually, we're probably not going to talk much about while. While is a similar, the things you can do with while are very similar to the things that you can do with a list. It just gives you a different way of sort of terminating the condition. So we'll talk about it eventually. All right, a for loop in Python, for those of you who know like C or C++ or Java, a for loop in Python is not the same as a for loop in those other languages. A for loop in Python allows you to do something for each element in a list, or for each element in some other object that looks like a list. So let's try what it says right there. Let's say A is equal to 13579, and I can say for I in A, print I. Oops, and I forgot the parentheses around my print. One of the differences between Python 2 and Python 3 is that in Python 2 there were no parentheses around the value in the print statement, and in Python 3 there are. Okay, so what is this doing here? Basically, this is saying for each element in the list A, assign that element to the variable I, and then do whatever you want to do in this block of code below. Okay, so very straightforward. You're not limited to just one line of code. So here you can say you can see I did print I. I could do something else, like I could say j is equal to I times 3. And then here I could print I comma j. Now, the thing to notice here, the most important part of this is here I've indented. In programming languages like C, the way I would do something like this would be I'd say for I equals int I equals 0, I is less than, I'm not going to use exactly the same conditions, I plus plus, and then I'd put curly braces in, and the curly braces would denote the beginning of the stuff I want to do inside the loop and the end of the stuff I want to do. Curly braces don't do that in Python. In Python, blocks of code are defined by indentation, and you have to indent by the same amount. This was probably done by Guido because he was frustrated with people who wrote programmed in languages like C who didn't use indentation to make their code look nice. So he's saying, well, we're going to use the indentation as the way you actually define the loops in the code. So people are forced to indent properly. So it gives you good visual indications, but it's a little different for those of you who are used to some other programming language. Anyway, so if you want to do things that are inside the loop, you have to indent. You can indent by however much you want. You can indent by a single space. As long as you use the single space for all of the lines that you want to execute, that's fine. It's still absolutely valid. So you can use spaces or you can use tabs. You're encouraged to use only one or the other when you write your code. Either use tabs or use spaces. Don't mix tabs with spaces because it gets really confusing and inconsistent. Now, if I did this, so my print statement wasn't indented, I would get this. So what happened here, it went through the loop, it looped over all of these different values, and here it assigned j is equal to I times 3, and when it finished the loop, I was set to 9, and j was set to 9 times 3, and then this code only got executed after that loop ended, because it wasn't part of the loop. So again, if I indent here, it's part of the loop. If I don't indent here, it's not part of the loop and happens after the loop finishes. Okay. Oops. All right, so back to our example. This is where we were before. Now we can convert this annoying program to something much simpler like this. So I can define the list of x values that I want to look at. Then I can just say for I and x, and I can print I and sign I next to each other and get the same result. Okay, I'd really rather not have to type out this whole list of numbers. Why don't we compute those numbers? So we could do that this way. What's this range thing? Range works very much like the slicing operation we learned about. If I say range, very much, but not exactly. If I say range 10, that creates a range object which goes from 0 to, but not including 10. Now you'd say, well, what's this range object? Well, this range object is an object that lets you use it in, say, a for loop, and it generates values on the fly. If you want it explicitly as a list, then we need to force this into becoming a list or a tuple. We can do that like this. So if we use list as a function, it will coerce another data type to become a list. So if I just say 10, it will start at 0 and it will go up to 10, not including 10, 0 through 9. If I say 3, 10, it will start at 3 and go up to 10, not including 10. Let me put list in front here, just so we get it. If I say 3, 10, 2, it will skip every other value. So this is very similar to what happens when you do slicing to extract substrings or portions of lists. Anyway, this allows you to generate ranges of integers very easily. You can't use floating point values in here. You can't have it step by 0.1 or by pi or something like that. It'll only do integers. Now later on, when we talk about a package called numpy, we'll see an equivalent operation which lets us work with fractional values. But here, if you want to generate fractional values, you have to do something with it. Like, well, that's actually what we're doing here. So we generate a list of integers, and then inside the loop, we convert the integer into a corresponding floating point number that we want to take the sign of. When I've given things like this as a homework problem in the past, sometimes you run into someone who does something like this. They have one loop where they modify the values of the range operation, and then they have another loop which does the printing. Unfortunately, this isn't maybe doing what those people thought it was going to do. First of all, you can't modify the values of range unless you convert it to a list. And second of all, when you loop over the list like this, the I, so basically, let's take this. Let's actually do it. Now, if I try to run this, what happens when I do this? What is x going to be equal to? Well, x is still range 0 to 9. So when you go through this for loop, what it does is it says, okay, take the first element of x and assign it to I. Now here we say, okay, I, instead of being the element that it was just assigned, I is now going to be that element multiplied by pi over 4. But it's not doing anything to x. All it's doing is changing this temporary value I. So if I look at I will be equal to the final value when the loop finished, but we're not doing anything to change x. Now, if we wanted to change x, we would have to do this a little bit differently. We would have to do something like this. Oops. Okay, now this would be sort of the straightforward way of doing it, but again, this won't work right either. Okay, so I created this range object. Now, instead of looping over the actual range object, I'm looping over another range object which has as many numbers in it as the length of the object. Okay, so len gives you the length of the range object. So if I say just len range 9, that will give me a 9. So it creates a new range object with a number of values. Now, in this case, it's kind of silly because the first value, they're going to be exactly the same. But if I said something like 5, 20 here instead, then the length of this, then this range would be counting over the elements in the list, and this range would be, let's just do it. Range, x equals range 520, and range len x. So you can see that this range is going from 5 to 20. This range is going from 0 to 15. So it allows you to access all of the elements in this range. If I put a 2 here, okay, now you can see there's only 8 elements in this range. So anyway, so I'm looping over all the values, and now instead of assigning to I, I'm trying to change the values in this input. But that won't work because it's a range object, and I can't assign values to a range object. See what it says here? Range objects does not support item assignment. I could do this if I change this to list. So I create a range object. I convert the range object into an actual list object. Then I do this loop to modify the values. And now if I print out x after doing this, I'll get a list of all the numbers that I was after. Now, it was probably easier to do that this way and not actually create an actual list that contains all of those x values and to just compute the x values on the fly, but you could do it the way I was just showing you. Okay. One other really cool thing that the Python language has, this is a very useful kind of shortcut. If you're trying to generate a list of deterministic values in some way, like we were just doing on this previous page, you can actually put a for loop inside a loop definition. So we've got square brackets saying that we've got a list, inside a list definition. So we've got square brackets saying that this is a list, and then inside the square brackets we're putting an actual expression. So let's give that a try and see how it works. So I'm going to say x times 2 for x in range 10. Okay, so this is kind of a backwards expression. So here's the for loop. This is the loop that it's going to use to generate the values. And the first thing before the for loop is the result, the computation that you want to do to compute the value. So it's going to compute x equals 2, x times 2 for each of the x values in this range. So if I do that, I'll get a list of 0, 2, 4, but etc. So I can put anything I like here. So if I wanted to say x times pi, I can do that. So any valid mathematical expression you can put here. And then the second part of the loop is just generating the values that it'll use. You don't have to use a range operation here. If you have another list, you could put that other list in there, and you can use that to create sort of a copy of the list, but with some mathematical transformation performed. So it's a really useful shortcut. Now, you don't have to do it this way. You can do it with the explicit for statement where you create the new loop one element at a time. This is just a very useful shortcut. And the reason I mention it now, even though we're just sort of starting out, is because you will see people use this a lot. So if you're reading someone else's Python program and you say, what the hell is this list-looking thing that's got a for loop inside it? Well, that's what this is. Okay, so here's sort of another version of the program where we use this list generator concept to generate the x values on the fly, and then we can print out the results. We can go ahead and do this just to show that it works, but well. Okay, one last little modification to introduce sort of our final concept here. Let's say we want to do exactly the same thing we were just talking about, but now we only want to include values where the sign of x is greater than 0. Why would we want to do this? I can't think of any reason at all. This is just an arbitrary made-up example. But if you want to put some sort of condition on the list that you're generating, how would we go about doing that? Well, here we've got our basic program. So this generates all of the values. So now our goal is to take out all the values which have where the result is negative, right? All right. So this is where we're going to introduce the if statement. If statements allow you to make decisions. So the for statement allows you to iterate over all of the elements in a list, to do something for each element in the list. The if statement allows you to ask questions. And if the question is true, you can do one thing, and if the question is false, you can do something else. So let's try something really straightforward. If 5 is greater than 2, colon, print yes. Okay, now, just like the for statement, you remember the for statement had a colon at the end of the line? The colon in Python says, begin a block of code. So after the colon, it's going to expect to find the next line indented to do something. So just like in the for statement, I can put multiple statements in here. I mean, I could say print, oops. So I can put multiple statements as long as I indent them the same way after the if statement, just like after the for statement. Now, what if I said if 5 was less than 2? Obviously, it won't do anything. So what if I want to do something if 5 is greater than 2, and I want to do something else if 5 is less than 2? Well, I could put 2 if statements in a row. That would be okay. Or I can say else. And whatever the, print, no. Okay, and if I change it back again, right? So basically the if statement, if the condition is true, it'll do whatever you say. If the condition is false, then it'll do whatever follows else. Now, what if you need to make a sequence of decisions? What if you want to do one thing if x is equal to 0, and another thing if x is equal to 1, and another thing if x is equal to 2, and then something else if x is not 0, 1, or 2? So that's where this elif comes in. So it's a combination of an else and an if in one statement. So you can say if, let's see, let's try, I'm going to start from scratch. We'll say x is equal to 5. if x is equal to 4, print 4. Now I'm doing something a little different here too. I'll explain in a second. Elif x is equal to 5, print 5, else print. Okay, now if I change x to 4, obviously it'll print 4, and if I change x to 10, it should, it should print something else. Okay, so you can start with an if, then you can have a series of elifs, and then you can finish the whole thing up with an else to catch anything that you didn't catch earlier. So this allows you to make decisions. Now the other thing you'll note is that instead of making a new line and putting some indentation on it, I just put the print statement on exactly the same line. So this is another choice that you have. Whenever you have a block of code, if there's exactly one thing you want to do in that block of code, you can put it immediately after the colon and put it all in the same line. If you need to do more than one thing, if you need to have two statements, not just one statement, then you need to do the indentation on the subsequent lines. But it allows you to make the code a little bit more condensed if you have very simple operations. Okay, so we've got an if statement. So now we can just sort of tack our if statement into the program that we had before. So this is exactly the same program, except now inside the for loop, I've put an if statement before my print. Oops. And in fact, I could put this on the same line if I wanted to. Now, I don't want to put the if on the same line as the for, because then I've got two colons on the same line, and that just gets really confusing. But I can put the print on the same line as the if easily enough. You may also notice that this character here, that's how it represents a tab character. I had a tab in the code that I copied in the in Keynote. Anyway, so we can do this, and now it's going to print out the results, and you can see it skipped all of the places where the sign was less than 0, or less than or equal to 0. Okay, so when we're dealing with if statements, oops, let me go back to that page because I skipped a little bit of that. Where was it? There we go. I sort of skipped quickly over this. These are the standard Boolean operations that you can use. You can say less than, greater than, less than or equal to, greater than or equal to, is exactly equal to, or the exclamation point equals means is not equal to. And then you have the illogical statements and or not in. So if you want to combine things, you can use and or. Not is basically, for equals, it basically inverts, if it's true, it becomes false. If it's false, it becomes true. And in is what we talked about before. It allows you to look for membership in a list. So you can combine fairly complicated expressions, right? You could say 5 is equal to 3 and 4 is equal to 4. And of course that's false. But if I say or, then it's true. So anything that returns a true-false answer can be used inside an if statement. Technically, anything that is numerical could actually also be used inside an if statement. So you can include things which have true-false answers. You can also use things which return numerical values. If the numerical value is exactly 0, that's considered false. If the numerical value is anything other than 0, it's considered true. Okay, that's it for our basic program flow discussion.